We have now got to the point where we've got loads of HCO3 in the respiring tissues. So the concentration of HCO3 is very high. So what do? This blood is in the capillaries. So this is now through the venous system, going back to the lungs. And we get back to the lungs and we're met with the same predicament. But here we've got lots of HCO3 minus and H plus. And what we do now is in the lungs, this is the alveoli, this airspace, it's meant to be empty. You've got low CO2 because you've just breathed in freshly inhaled air, fresh air. What that does is causes CO2 to diffuse this way. By CO2 diffusing that way, you are lowering the concentration of CO2. If you lower the concentration of CO2, you guessed it, you get this. You get HCO3 turning into CO2. But that raises the partial pressure of CO2. So it diffuses again. And then that causes that CO2 to go down, which causes changing in the dynamic equilibrium, which causes the CO2 to diffuse this way. And eventually you get quite a lot of CO2 diffusing across. But then you breathe out. So you get all that CO2 and you breathe it out. And you get fresh air in. And that fresh air has low CO2. And when there's low CO2, some will diffuse. And that causes dynamic equilibrium to shift. And eventually, all those HCO3 does have to re-enter the red blood cell, by the way, to go into this, but it's the same protein channel that does it as before, but you don't need to know that. So you get rid of all the hydrogen carbonate in your blood and in your red blood cells, and it just goes into your alveoli and you blow it out. And that is how carbon dioxide is transported within the body. It's just fiddling these dynamic equilibriums here and here.